Hello guys and welcome back to my channel Interview with Bunny, and we are back with another question on system designing, and the topic or the application that we will be designing today is called as the collaborative text editor such as Google Docs. So this is nothing but a straightforward implementation of the Google Docs where we will be seeing and designing in detail that how multiple users can simultaneously edit and modify a particular document. So without wasting much time, let's get started with the system designing of the Google Docs. So as you guys are already familiar with how the Google Docs actually works, so I won't be wasting too much time on explaining the application. Rather, we will start with the first step of our designing, and that is the collection of the functional requirement. So the functional requirement of this problem is quite simple and straightforward. Number one, user will be able to create, modify or delete a particular document. Number two, multiple or the single user should be able to collaboratively or single-handedly edit a particular document. Number three, in case of the collaborative approach, means when multiple users are performing on the single document, we will be able to see that what are the changes that are made by the other user in the near real time. Number four, user should be able to see the cursor position of the other user and the presence of the other user in the application, means whoever are right now active and are updating the document simultaneously. And the last but not the least, and that is the versioning of the file. So for example, just like the Confluence page, a Google document can also have multiple version in the backend. So these are primarily the five main or the major functional requirement that we have to solve over here. So let's first list down all the functional requirement that we will be solving in this video. So as we were discussing, these are all the five functional requirements that we will be going to solve here. Now let's go to the next important thing, and that is the collection of the non-functional requirement. So as we know, the first non-functional requirement that you have to gather from your interviewer is the scale of the system, because without understanding the scale of the system, it will be very difficult for you to design, because generally depending on the scale of the system, your system designing should also change accordingly. So the first requirement that we will be gathering over here as the part of the non-functional requirement will be the scale of the system, and here we will be supporting a millions of users, and the total number of documents that we will be saving in our backend or we will be handling in our backend will be in the count of the billions. So here you can easily understand that since we are mimicking the Google Docs, so obviously here the scale of the system is massive. So here the scale of the system will be something like this. That is, we are supporting millions of users, and the total number of documents that we are handling in the backend will be in the count of billion. Now the next non-functional requirement that we have to gather for all our system designing, and that is the cap theorem. And as you know, based on the cap theorem, whenever you are creating a distributed architecture or a distributed system, you either have to compromise between the high availability or high consistency. A particular module cannot have both of them together. So here if you look carefully, our application should be highly available rather than highly consistent in some part of the application. So for example, whenever we are talking about an offline document, this when no two users are collaboratively editing a particular document, then we will be preferring a high availability rather than high consistency, because at that time it is fine that whenever I edit something, after a lag of 1 or 2 seconds, the second person when he opens the document will see all my changes. But in case of collaborative approach, means when user A as well as user B are updating the same document simultaneously, then at that time the consistency of the document should be the first preference. Means as soon as user A makes some changes on the document, that should get reflected to user B in the near real time. So here we will be specifying it clearly. That is, our system on a whole should be highly available rather than highly consistent. Means here we can go with the eventual consistency. But in case of the collaborative approach, there we have to give the preference of the consistency more. Hopefully you have understood. So let me keep that note over here. And number three, the latency. And here latency means whenever multiple users are trying to update the document simultaneously, at that time the edit updates between the user should be as minimum as possible. And here we will be considering a latency of 100 milliseconds. So these are more or less all the functional and the non-functional requirement that we will be solving over here. So here you can see this is quite a straightforward requirement gathering round, because over here the application is quite simple. That is, we have to create an online document where user will be able to write text, collaboratively, or independently. So this is the primary goal of this application. Now since we are done with the first step of our designing, and that is gathering of the functional and non-functional requirement, let's now go to the next step of our designing, and that is the identification of the code entity. So let's see what will be the code entities that we have to design over here. So here if you go through the functional requirements that we have gathered over here, you can easily identify that there are a couple of code entities. Number one, the user or the editor who will be actually making the changes in our document. So the first code entity will be the user. Number two, obviously the user will be updating the documents. So the next code entity will be the documents. Number three, here if you look carefully to the second point, here you can see that here it is telling that the multiple users can edit the same document simultaneously. Means here the next primary attribute that we have to consider is the edit. Means whatever the changes that are taking place within a particular document. So that changes we will be calling as the edit. So the next code entity will be the edit. And the last but not the least is like we have to locate and save the position of the cursor of each and every user, those who are modifying the files simultaneously. So here the next code entity will be the cursor. So these are more or less all the core entities that we have identified as of now. So there can be plenty more entities that will be meaningful and mention worthy, but we will be identifying it once we find out or once we will start the designing. But as of now, just by reading all the functional requirement, we have only managed to find out all these four core entities over here. Now let's go to the next step of our designing, and that is the crucial step, and that is the API designing. So let's go to the third step of our designing, and that is the API designing. And as I always tell you, API designing is very simple if you have gathered the functional requirements correctly. Because in most of the cases, API endpoint have one-to-one or one-to-many relation with all the functional requirement that we have gathered. So let's see what will be the major API endpoint that we will be exposing in our application. So the first endpoint that we have to expose over here is for fulfilling the purpose of create, delete and update a particular document. And as you know, whenever a particular user is creating the document for the first time, means he is submitting some information into our database, and that is why it will be a post call. So let's see how the signature of this endpoint to create a document will look like. So this is how the first endpoint will look like. So it is quite easy. That is, it is a post call, and here what we are doing, we are exposing a create API, and with the help of this API, user will be able to create a document. And what will be the return type for this API? And that is nothing but a document ID. Now let's see what will be the next endpoint that we have to expose. So obviously once the document is created, the next thing that we have to give to the user is for viewing a particular document. So obviously we need a get endpoint so that the user can view the document, what are the content that is present in a particular document. So for that, here we will be exposing our next API, that will be a get API, since we are trying to fetch some information from our database. So the next endpoint will be a get endpoint, and let's see how it will look like. So this is how the endpoint will look like. So here you can see we are passing the document ID which we want to retrieve from our database, and this document will be in the read-only mode. Means user won't be able to make any changes, but he can only view the document. Clear? Similarly, here we have to also give the provision to delete and update a particular document. So these are all the CRUD endpoint that are required to modify a document. So this will be quite simple. So I'm not listing it over here. You can easily mention it during your interview. But let's go to the next major endpoint that we need, and that is editing a document. And whenever I'm telling that editing a document, it means that you will be editing simultaneously with other user, or it can be a single user. So here we will be giving a provision for multiple user to join in, as well as you can single-handedly edit a particular document. And remember, when we are actually editing a document, we are not doing it with the help of the REST API. What we are doing? We are doing it with the help of the WebSocket connection. So here I will just mention it, how the signature will look like. After that, I will tell you that why we will be selecting a WebSocket connection over here to update our document, and what are the other things that we have to pass over there. But as of now, I'm just mentioning it that here we just need a WebSocket connection to edit a particular document. I hope this is clear. But believe me, there are a few more endpoints that we need to fulfill all the requirements that we have gathered over here. But as of now, I am not listing all those things right now. When we will be implementing the high level as well as the low level designing, there at that time I will be keep on updating this list accordingly. So here we are more or less done with our third step of our designing, and that is the API creation. Now let's go to the next step of our designing, and that is the high level designing of our application, where we will see that what are the modules or the core entities that are needed to fulfill all the functional requirement that we have gathered. So let's jump to the fourth step of our designing, and that is the high level designing of our application. So the high level designing of the Google Docs is actually pretty simple, because here if you look carefully, the functionality that we have gathered is quite straightforward. Means there will be few users who will be creating a document, and obviously that document should get persistent in the backend, and also there will be some provision so that multiple users can able to modify the same document concurrently. So let's see how we will design that architecture over here. So the first thing that we will be doing here, we will be mentioning some of the clients or the user who will be actually involved in our application. So here I will be drawing few of the clients or the user. And it is pretty obvious that since here we are targeting a millions of users, and here we are updating a billions of documents, so obviously we won't be going with a monolithic architecture. Rather, we have to go with the microservice architecture, where each and every server will be responsible for doing its own core functionality. So obviously here what we need a load balancer or the API gateway to handle all the traffic and distribute all the traffic in a uniform way across all our backend server. So what we need our first component, and that is a load balancer or a API gateway. And as you know, the functionality of the load balancer and API gateway is quite simple, and that is number one, rate limiting; number two, distributing the traffic uniformly across all the servers; number three, authentication and authorization. And here when we are telling that we will be using a load balancer, here we will be going with a round robin algorithm, means all the backend server will get the traffic uniformly. So let me list down all those points over here so that it will be easy for you to understand. I hope this is clear. So what is happening? All the users are first hitting our load balancer or the API gateway, and based on our URL endpoint, our API gateway will route the traffic to the respective server. So let's see what are the servers that are needed, or what are the backend components that are required over here to fulfill all our functional requirements. So here if you understand, the first component that we have to design over here is we have to give the user the provision to create, delete and update a particular document. So here what I will do, I will create a backend service called as the document metadata service. And the responsibility of this service is to create a document or change the metadata of a particular document. So very simple. So here if you understand it clearly, whenever you are creating a document for the first time, what you are doing? You are just submitting some of the information, means what will be the title of the document, who is creating the document, what is the timestamp at which the document was created. So all the provision to change or create those metadata will be handled by this document metadata service. I think this is clear. So obviously all this information also need to be persisted in the backend, and for that we need a database. So here I will be creating a database. So this will be my document database, which will consist of all the metadata of a particular document. So here keep this thing in mind. This is not the actual file that we are storing. Here we are storing the information or the metadata of a file. Means who have created, what is the title of the file, all those things. So those things are getting stored here in the backend with the help of this document metadata service. Now comes the main thing, that is here if you look carefully, we have created the metadata of the document. But here where is the actual document file or the text that is there in the document? So for that what we are doing, here we are not saving that Word document in the database. Rather what we are doing, we are using a blob storage or a S3 bucket to save all those information. Because obviously you can understand that a textual file can have lot of information on a particular document. Means it can have thousands of lines of text, and the size of that document file will depend on the total number of textual line that is present within that Word document. And here it is not advisable to save all those heavy files in a normal database. Rather, what we will be using here, we will be using our simple blob storage to keep the original document file in our backend. So here what we'll do, I will create one more service or one more component, that is a blob storage. And this blob storage will actually have all the textual content on a particular file. I think this is clear. Now let's see the main thing, and that is how the user will be editing a document. So obviously here, since we are going with a microservice architecture, so here we have to create another component which will be handling all the major functionality of updating a particular file. So for that, what I will be doing, I will be creating one more service, and probably one of the core component of our application and the heart of our application, and that is the document editor service. So I hope you are clear with the two components or the two services that we have defined over here. So the first one is changing the metadata of a document, and the second service is changing the content of the document, means whatever the text that is present within the document. So here, if you understand the flow correctly, what is happening, once the user comes to our application, what he will do, he will first create a document, means he will submit some metadata into our backend, and that is done by the document metadata service. So here, this service will create an entry in our document DB, as well as it will create a document file in the blob storage. And once it gets created, it will return a document ID over here. And once the user try to open that document with the help of the document ID, this second endpoint will trigger. Means based on the document ID, we are again fetching from our blob storage using this document metadata service. And whenever the user want to edit that document, at that time what is happening, a request is coming to our document editor service, and here all the edit of the document is taking place. And once all the edit operation is done and the user clicks on submit, then that document gets persisted within that blob storage. Means a file got created, it got override with new text or content, and after that, once it is saved, that file again got persisted in the blob storage. This is the clear flow of how we are creating a document and how we are editing a particular document. Now, if you see here, we have explained it very simply that how to create a document and how to edit a document. But believe me, this is not at all simple as it looks like, because in the backend, there are plenty more things that are actually happening over here. Let's go into the detail one by one. So the first thing is like the first functional requirement that we have to fulfill over here, that is multiple users should be able to edit the same document. But here, if you look carefully, here we are showing a normal API endpoint to modify a particular document. And if you know, and if you have watched my 8th video on this playlist, you will be seeing that there I have developed the chat application. And there I have clearly told that while we are interacting with multiple people simultaneously and we need the real-time feedback from each user to another in the near real time, here at that time, we cannot rely on the normal REST endpoint. There what we have to do, we have to go with the WebSocket connection. So if you are not still clear with what is a WebSocket connection, why we need a WebSocket connection, how it is established and all those things, I will highly recommend you to go through my 8th video on my channel where I have discussed in detail that how a WebSocket connection get created, how we persist a WebSocket connection and all those things in detail. So for this video, I will skip all that part. So here I will just inform you that this connection will not be a simple REST endpoint. Rather, it will be a WebSocket connection where we will be having a bidirectional connection so that more than one user can simultaneously edit and update the document and we can see all the changes in near real time. So this will be nothing but a bidirectional duplex connection, and this will be a WebSocket connection. So here you have seen we have done more or less the high level designing of our application. So here we are having our first backend server that is handling all the metadata of the document, and here we are having our core server, and that is the editor server where multiple users are trying to update a single document with the help of this WebSocket connection. But there are plenty more things that you need to know, because editing a particular document is not at all simple as it looks like. Because you can easily understand that if multiple users are trying to change a particular document, there will be a lot of conflict and the issues that will be coming on the runtime. So for example, there is a word called as API designing, and here I want to change this title from API designing to something else. Similarly, the user B, who is also editing the same document, he want to add a space at the very end. So here you can see there's a conflict, means here I want to change the text and a different user is trying to append the text at the very end of this text. So here there is a conflict that we have to resolve on the near real time. So let's see how we will be doing all those things and what are the specialized algorithm that is there to resolve all this conflict in near real time. So let's go to the next step of our designing, where we will be seeing in detail that how this core functionality, that is the document editor service, will get implemented, because there are a lot of concepts that you need to know and lot of algorithms also that you need to know to design a collaborative system such as a Google Docs. So let's move to the next and the last step of our designing, and that is the low level or the deep dive designing of this system. So let's go to the next step of our designing. Before proceeding further, I just wanted to notify that I have created a very simple website over here so that you get all the contents that I upload on the YouTube on a single platform. So here you can see there are lots of content on the system designing, on the low level system designing. Similarly, here we have the complete graph playlist where we have already 15 to 16 video over here, as well as all the latest contents that I'm uploading on the YouTube. I will keep on updating all those things in this website. This is a free website that is hosted also in a free domain. So do not forget to bookmark this website so that it will be helpful for you to find out all the relevant contents regarding your upcoming interview. So let's start with the low level designing. So the first thing that I will do, I will copy this entire design from the high level into our low level section. And let's start with deep dive analysis of each and every component that we have defined over here. So let's start with the first component, and that is the document metadata service. So as you have already understood that the main functionality of this service is to update the database regarding all the metadata of the files. Means whatever the Google documents that you are creating, all those metadata are getting submitted with the help of this service. And if you look carefully, the total amount or the scale of the system is quite huge, because here we are targeting millions of users who are actually editing a billions of documents in the backend. So you can easily understand that the total number of edit requests for all the documents will be pretty huge. So it is quite obvious that our database will not support that volume of data per second. So what we have to do, we have to keep a buffer in between this document service and this database which is getting updated. So let's see how we can enhance this design. So what we will do, here we will introduce a buffer service, something like a Kafka queue. So here I will introduce a queue called as Kafka queue. And all the updates regarding the metadata will come from this metadata service, and it will get submitted within this Kafka queue first. And from this Kafka queue, there will be a consumer service which will read all the events of modifying a particular file, and after reading that event, it will update the database accordingly. So it is generally a purpose design pattern to update the database when the write request on a particular database is quite heavy. So here what we have to do, here we have to introduce another service called as a consumer service. So I will write it as metadata consumer. I think this is clear. So what this document metadata service is doing, it is handling all the requests to update the metadata of the document. So let me write it over here. Now let's see what will be the database that we will be choosing over here to save all the metadata of the document. So since this is a simple flat file of information about all the metadata of a particular document, you can easily go with any type of database. You can either go with a Postgres database or a MySQL database just to have information of the metadata. Otherwise, what you can do, you can go with a write heavy database, that is a Cassandra database. So I will go with a Cassandra one over here. Now let's see what are the attribute or schema structure that we will be saving for the metadata file. So these are more or less the primary attribute that we need to save the metadata of a file. So that is normally a auto-generated ID, the document ID, the title of the document, the URL, means the blob URL where the actual file is located. After that, the created by, created time, last modified by, and so on. So there are a pretty huge amount of metadata that you have to store in this metadata database. So I hope this is quite simple and clear. Now let's move to the next step and probably one of the crucial thing, that is the document editor service, which is the heart of our application, where we will discuss in detail that how multiple user will be updating the single document collaboratively and how we will resolve all the conflicts in near real time. So the first thing first, what we have considered during our high level designing, that is here we are using a WebSocket connection. Now let me give you a brief justification that why you actually need a WebSocket connection rather than a normal HTTP call. So here if you look carefully into our problem statement, you will get to know one thing, that whenever two or multiple users are trying to update a particular document, we have to show all those changes in near real time. Now let's see how we can solve this problem statement. So let's solve this problem first by a very brute force approach. So let's take an example that this is a single file and there are two users who are concurrently modifying this file. This is user A and this is user B. Now to achieve a collaborative document or a text editor in near real time, what we can do is like, for example, the user A have typed something in the document, that is ABC. And as soon as the user A have submitted this in the text file, what we will do, we will simply make an HTTP call in our backend, and thus here our document editor service will persist this ABC in the database, and thereafter whenever there is a change or modification on this file, what will happen? A push notification will go from the server to the client using the SSH connection. So I hope you already know what is a WebSocket connection, what is a SSH connection, and all those things, because I have already told you that in my 8th video on my channel where we were discussing the chat application, there I have discussed in detail about all the connection that we normally use while designing the system. So with the assumption that you already know that what is a SSH connection, let's proceed further. So what will happen? Once the user A types something in the document, a simple HTTP request will go, and whenever there is a change or modification in the file, another SSH request will go from the server to all other user, that is user B over here, that there is a change in the file, and thus all the changes will get reflected on the local copy of user B. So this can be one of the approach of solving the problem. But here you can easily understand that there is a critical problem with this approach. That is, for example, the text file the user A is updating is pretty huge. And whenever there is a change on that text file, we are submitting the entire data into our backend, and then a push notification is going to all the other connected users who are also editing that document, and thereafter the front end is getting reloaded and all those changes are getting displayed in the front end. So with this approach, there are two major problems. Number one, since here we are submitting the entire file into our backend, so obviously the request will be very heavy, and each and every time a user is changing a single bit of information in the file, we have to keep on submitting the entire file in the backend, and thereafter we have to fetch that modified file for all the user in near real time. So here you can see there will be thousands and thousands of requests that will be going to and fro between the client and the server, which is actually not a possible and a feasible solution for making this type of application. So the first approach that we have discussed over here is called as the file replacement design. So the first solution can be a brute force solution that is called as the file replacement, where what we are doing, we are submitting the entire file into our backend, and thereafter we are fetching it for all the other users so that they can see all the latest change that other users have made. So this was the first way of solving this problem, and hopefully you already got that what can be the problem with this approach. That is, total number of submit and the fetch requests will be pretty heavy, and there will be millions and millions of requests that will be going between the client and the server. So we cannot rely with this solution. Now let's see what can be the other solution that is possible. So the other solution that can be possible is a simple locking protocol. That is, Whenever a user A is writing over here, what we have to do? We have to log this document for user A, and once the user A is done with all the changes that he wants, thereafter we will be unlocking this document for other user. Thereafter, some other user can again keep the log and update the document accordingly. And with the help of that approach, we can easily create a document file where multiple users can change the document, but it won't be a concurrent update, because as soon as the user A logs that document, it is not possible for other collaborator to edit that one until and unless user A release that document. So this is more or less the same way we have designed our ticket booking application, where if you have remembered, we have locked few of the seats for some definite amount of time, and once that lock was removed, thereafter the second person can book the same seat if the user A have not confirmed the booking. So this is the same way how we can give the feature of modifying the same document among different people together. So the second way of implementing this feature is with the help of the locking protocol. And just for your information, I would like to tell you that locking can be of two types. Number one is the pessimistic locking, and another one is the optimistic locking. And the real-time example between the optimistic locking and the pessimistic locking are as follows. So the real-time example of the optimistic lock is the git merge. So for example, two developers are trying to modify the same file together. So what we have to do? We have to first pull all the latest changes on a particular file. Then in our local, if there is some conflict, we have to resolve it over there, and then we have to push it. And in the meantime, if the second developer have already pushed his changes, then there will be a conflict in the backend and we have to resolve it manually. So that is an example of the optimistic lock. I hope this is clear. And the example of the pessimistic lock is the banking application, where we follow the async property. So these are the two type of locking protocol by which we can somehow create a document where multiple users can work together. But here you can see, till now we have not found a solution where multiple users can change a document together simultaneously and collaboratively. So let's move to the third way of solving this problem. So if you recollect, the first way by which we were solving the problem, there we had two major problems. That is, the total number of file size was quite huge, because on each and every modification on the client, we were sending the entire file into the backend. And the next problem was, since we were hitting the server on each and every keystroke or each and every modification, so the total number of requests between the server and the client was quite huge. So if you just think logically, there are some solution to solve both the problem. That is, the first problem was the size of the file. So here what we were doing, we were sending the entire file in the backend. So that can easily be solved if we just stop sending the entire document. Rather, we only send all the changes that are made within the document. So let's take an example that there is a huge document that both the user A as well as user B is viewing and modifying concurrently. And what happens is, like, user A wants to add a new character between these two W. So what he does, he have written a new character R over here. So in our first approach, what we were doing, we were sending this entire file in our backend. But in this case, to resolve this issue, what we will do, we will not send this entire file in our backend. Rather, what we will do, we will only send the delta of the changes. Means here, since he have added this R in this position, so we will only send that much information to our backend server. So for example, at this position 29, he want to add a R character over here. So in the backend, what we will be sending, we will be sending a command like user A want to add a R at position 29. So this is the only information we will be sending to the backend, rather than sending the entire file and increasing the payload size. So here you can see we have already solved one of the problems that we were facing in our file replacement algorithm. Now what was the second problem? That is, the total number of requests that is going between the client and the server was quite huge, because at each and every time whenever there is a small insert in the textual file, then we have to send that information to the backend, and thereafter this server have to push that notification or change to all the clients or the user who are connected to that document. I think this is clear. So To optimize this, what we can do here, instead of sending this much amount of the request between the client and the server, we can establish a WebSocket connection so that we can omit the total number of requests that are going to and fro between the client and server, because a WebSocket is a bidirectional connection. So whenever there is a changes that is coming from the user A to the server, it will be coming through an open socket, and thereafter the response will also go to all other users who all are also connected with other WebSocket connection. So with the help of that persistent connection, we can easily solve the second problem that we were facing during the file replacement. So I hope you are clear with how we have solved the two problems that we were facing on the first solution that we have proposed over here. So what we are doing here, instead of sending the file altogether, we are sending the events or the change requests that are happening in the file. And here, instead of using a simple API connection, we are using a WebSocket connector. But with this solution, there is some crucial problem that we will see right now. That is, for example, both user A and user B is trying to edit a single part of the document. And whenever both the user are trying to edit the same word together on their client side, at that time there will be a conflict in the backend. Let's understand this with the help of an example. So let's take an example. We have two users, Alice and the Bob. So this example is easily available in the Google. So I have just downloaded it from the internet, and I do not know what is the source of this, but this example is very much valid. So let's see what can be the problem over here. So here, if you see, we are having two users, Alice and the Bob, and both of them are collaboratively opened a single document where there is a string called as BC. Now what happens is like Alice wants to insert A at position 0. So what happens is like Alice made an insertion on the first position of the string, and thus in his local, the string is now A, B and C. And similarly, on the same time, Bob also want to make the changes on the same string. And what he want to do? He want to insert D at position 2. So what he have done? He have inserted D over here. So at the client side of the A, the string is ABC, and in the client side of B, the string is BCD. Now what is happening? The change event got triggered from both the client that there is a similar change that happened on each other, and thus in the front end we have to resolve the conflict. And to resolve the conflict, what the client side will do, it will try to insert the D at position 2. So after inserting D at position 2, the client side of the Alice will look something like this, that is A, B, D and C. That is D got inserted over here, which is done by the Bob, and this A has been inserted by the Alice in his front end. So the string will look like ABDC on the front end of Alice. But in the document file that has been opened by Bob, over there, it will look something different. Because in the Word document of the Bob, the string was B, C and D after the insertion of the D at position 2. And as soon as it gets a notification by the WebSocket connection that user Alice have inserted a A at the position 0, so then it will also try to modify it accordingly. And thereafter what it will do, it will insert the A at position 0, and thus the string will become ABCD. So here if you look carefully, both of them are right at their position because Alice have inserted A at the position 0. Similarly, Bob has inserted D at position 2. And since Bob has inserted D at position 2, so also based on this string, we have also inserted D and thus resulting into ABDC. Similarly, over here, this is A, B, C and D. But if you look carefully as a whole, there is an inconsistency between the client side of both the user. Means though two users are trying to make changes on the same string on the same Word document, but the representation of the string is different for Alice and for the Bob. So here you can see the way we are reconciling the data in the front end of the user A and the user B is actually creating the problem. So here the algorithm that we are using to reconcile the data is wrong, which is actually causing the inconsistency across the file. So this approach is also not a possible solution to solve this problem. So let's now see what can be the other way or other algorithm to solve this problem. So here if you have understood it correctly, the way we are sending the data into our backend is correct. And here also we are using the WebSocket connection, that is also correct. Only thing is like the way we are reconciling the data. that is not correct. So we have to see what are the algorithms that are available to resolve this problem. So the two most popular algorithms that are available for this type of collaborative approach is number one, the operational transformation, and number two, conflict-free replicated data type. So let me write both the algorithm over here. After that, it will be very easy for you to understand that what is the algorithm all about, and with the help of those algorithms, how we can solve this problem. So here you can see these are the two solutions or the two algorithms to solve this collaborative approach problem. So we will discuss one by one because this is actually the core concept that you need to know to solve this problem, because during the interview you have to explain this two way of how we can solve this problem. That is only the main concern over here. So let me tell you one by one that what is an OT and what is a CRDT and when it should be used and when it should not be used and everything regarding this algorithm. So let's discuss with the first algorithm, that is the operational transformation or called as OT. So the algorithm states that the OT transforms the concurrent operations during merging, and the transformation function ensures that the effect of an operation is adjusted to account for the changes made by the other operation. Let's understand it in the layman's language. So here if you look carefully with the example that we were discussing earlier, what we were doing. So for example, we have the same string that is BC, and what Alice did, Alice have inserted at position 0, so the string become ABC in the Alice end, and what Bob did, Bob have inserted D at the position 2, so the string become BCD. So in our previous approach, what we were doing, we were simply passing these changes or the event in the client side of the other, and that is why there was an inconsistency across the client. And here to resolve that issue, what we are doing, we are taking the help of the algorithm called as OT. But here what we are doing, here instead of just blindly sending the instruction that is insert D at position 2, what OT does, that is it internally understand that what is the changes that are made by the other client, and based on that only it transforms the instruction accordingly. So here if you look carefully, what Bob have inserted, he have inserted D at position 2. But while passing this event from Bob to Alice, what this OT did, it had changed the instruction. That is right now we are inserting D at position 3, not at position 2, because this OT have understood that Alice have already inserted A at position 0, and that is why this algorithm have shifted this transformation by 1 bit, and thus the transformation that happened on the client side of Alice resulted into A, B, C and D. I hope this is clear. Similarly, on the client side of the Bob, it got changed to ABCD that we have got previously. And thus here you can see that both the client end are having the same string. Means we have found out a solution of how to do a collaborative way of editing a single document concurrently by multiple users. So here this is the operational transformation algorithm which actually does all the changes internally. So this is the first algorithm, but obviously this algorithm have some limitation. That is, all the operation must go through a single server which does the transformation. Means both user A and user B should be connected to the same server to update the same document. Otherwise, this algorithm will fail. And the second limitation is implementing this algorithm is very complex thing, because here you can see in near real time, these algorithms have to judge that what is the other person is also doing on the same document, and that is why this algorithm become a bit complex. But this is what the operational transformation algorithm states. Let's now go to the second algorithm, and that is the CRDT. So this is quite a simple way of implementation. So what this CRDT tells that this is nothing but a data structure designed for distributed system that automatically resolve conflicts caused by the concurrent updates. So it is totally not an algorithm rather than a data structure by which we resolve the problem across the different users. Let's see how this data structure actually works. So here if we take the same example, here you can see we are having the same string, that is B and C. And right now you can see there is an index that is given over here, that is B is placed at position 0,5 and C is placed at position 0,75. Now, once Alice is trying to add particular string at the very beginning, what we are doing, we are not making it at the 0th position. Rather, what we are doing, we are telling that before B, we have to assign a value to it. So here the insertion value is A at position 0,25. So the string got changed to ABC, and here you can see the valuation or the position over here is 0.025, zero point 0.5 and 0.75. Similarly, in the client end of the Bob, here he want to insert D at the very end, and that is why we have taken a value or the position which is more than the last position over here. So what we are doing, we are inserting D and the value that is given is 0.875. Now, when we are reconciling the data together, what we are doing, we are simply arranging the word based on the position value. And that is why you can see at both the end, that is on the client side of the Alice and the client side of the Bob, represent the same value. And thus we are making a consistent data structure over here where multiple users can update the same document simultaneously. So these are pretty much the two main algorithms, that is the OT and CRDT, which are used across the world to solve this type of problem. But in case of the Google Docs, Google actually uses this OT way of solving the problem. So going forward, we will be discussing only this way of solving the problem. That is the OT way, that is the operational transformation. Now, since you have understood that how we should send the data to the server and how we should reconcile the data on the client as well as in the backend, let's now see how we can enhance this complete design to support this algorithm and to support this entire application over here. So now, since you are familiar with both the algorithms by which we are designing an online collaborative platform, now let's see how we will incorporate those design in this low-level design. So the first thing that I will do, I will move this content a bit down so that I get enough space for further designing. So the first thing that you have noticed over here we are using a WebSocket connection. And if you have remembered in my 8th video where we were discussing about the chat application, there I have told you clearly that if your application is WebSocket heavy, then it is better to deploy a separate WebSocket API gateway dedicated only for WebSocket connection. Though all the modern load balancers are capable enough to handle both the HTTP request as well as the WebSocket connection, but it is better to have a dedicated API gateway if your application runs primarily on the WebSocket connection. So what I will do, I will create a WebSocket connection and a gateway over here to handle all those traffic. I hope this is clear, and right now this document editor service will no longer be talking with this API gateway, rather it will be talking with the WebSocket load balancer that we have defined. So I will push it down and let me just redraw all these things one more time so that it will be easy for you to understand. I hope this is clear, means all the HTTP requests will be getting served by this API gateway and all the WebSocket connection will be getting served by this WebSocket load balancer that we have designed over here. Now let's start with the further development and further designing of this document editor service. Now, if you have already understood the OT algorithm that we were discussing right now, you must be knowing that this OT is getting performed in both the front end as well as in the back end. Means in the client side also we are performing a OT over here. Similarly, in the server side also we will be performing a OT in the back end. So let me just write it down over here. After that, I will explain you that why we need an operational transformation both in the front end as well as in the back end. Let me just label it over here. But as of now, you already know that we need an operational transformation in the front end so that whatever the edit operation that are happening with the other user, we can show it in near real time. And that is why we are having an OT in the client end. Now let's see how we will do and how we will handle all this operation in the back end. So the first thing that happens is like once the user logs into our application and try to access a document, a normal API request will go to this document metadata server to fetch the file from this blob storage. And here the blob storage is nothing but a S3 bucket. And thus from this S3 bucket, the file gets delivered to the front end in the read-only mode. Now, if the user have the access and request for a write operation, what happens is like a WebSocket connection gets established over here with the document editor service. Now, as I've already told you in my previous video, all WebSocket connection is basically a HTTP request at the very beginning. So first a HTTP request comes over here, and after that, that HTTP connection gets converted into a WebSocket connection. And how this connection is built or maintained, that I have already explained you in detail in my chat application, that how we should maintain stickiness in the connection and all those things. So what is happening in the backend is like, all the WebSocket application have a WebSocket registry from which the backend service gets to know that which user have an open WebSocket connection and in which server it need to connect. Because if you have remembered, while we were discussing the limitation of the OT, there I was telling that the first limitation of the OT is that all the operation must go through a single server. Means, for example, n number of users are trying to modify a single file, then all the n number of users should be a part of a single server in the backend. And to maintain that type of stickiness, you need a WebSocket registry in the backend. And how it is done? It can easily be done with the help of the consistent hashing and all those things. So I'm skipping all those things because we have already discussed it in detail in our earlier video. So with the assumption that you already know how the WebSocket connection is getting established, so what is happening is like, once the user raised a WebSocket connection to modify a document, this document editor service first fetch the document from this S3 bucket. So right now a copy of the file is with the client and one more copy is there in the backend server of the document editor. Now as soon as the user A makes a changes in the local copy of the document, a edit event get generated and it comes to this document editor service with the help of the WebSocket connection. And as soon as the request come to this document editor service, what happens is like, it does two things. Number one, it persists that event in the backend for durability, so that all the events that are doing by the users should get persisted and can be rolled back. And thus what is happening, all the event that is coming over here is getting persisted in a database. And obviously there will be millions and millions of edit requests that will be coming, because you already know that on each and every keystroke there will be an event that is getting triggered, and all those events are getting persisted with the help of the pub/sub mechanism that we have discussed over here. So here also all these requests will get dumped in a Kafka queue, and thereafter there will be a consumer service to consume all this event and submit it in a database. So here we will be having a database, and here we will be having a consumer service which will persist all this event in the database. So let me just name it as operation consumer service. I hope this is clear. Means all the micro events that are getting generated by the user are getting submitted in the database in the backend, so that we can persist and roll back whatever the changes they are doing. So this was the first action that is doing by this document editor service. Now the second action that it is doing is like, it is changing the local copy of the same document that it had fetched from this S3 bucket. And how it will modify those thousands and thousands of events in the near real time, it can only be done if we keep that local copy in memory. So what we will do, here we will define a Redis cluster, and this Redis cluster will keep a canonical copy of the document over here. So here in this Redis cluster, the canonical copy of the server remains persistent. So in the backend, whatever the event the user is triggering, we are performing the OT on all those events by keeping the canonical copy in the Redis cluster. So whatever the temporary state of the file, we are keeping it here in the Redis cluster, and all the permanent files we are keeping it in the S3 bucket. If you are still confused, do not worry. Once we do the entire flow, it will be very easy for you to understand, because everything is linked quite heavily. Now let's see what will be the schema structure of the database that we have defined over here. So this DB is nothing special. It only have the information of all the events that is getting generated by the user. So let's see how the schema structure will look like. So this is the schema structure of the operation DB. So it have the document ID, the timestamp, the event, the data, and all the other metadata that is required. So this is quite simple. So here if you look carefully, we are almost done with the designing of the entire application. Only there are small parts that are pending that I will be explaining you very soon. So right now let me tell you the data flow, that how everything will be working over here. So let's take an example that there is only a single user who is editing the file. So what is happening? The request will first come to the document editor service, and thus a copy of the empty file will be fetched from this S3 bucket and it will be put in the canonical copy over here. Now whatever the changes this user A is doing in the front end, there is no conflict, there is no problem. So whatever the things that are happening over here in the front end, similarly all those things are also happening in the back end. Now once there is some update in the document, user B comes into the picture and he wants to edit the same document that user A is already doing. So what happens is like user B try to fetch the document, and for fetching what is happening, the request will go to this document editor service and it will fetch an empty document from this S3 bucket and it will come to the client side of the user B. But remember, right now the document file is empty for user B, but there is some content for the user A, though they are using the same set of document. So there is a small problem or a small gap over here because the temporary file where the user A is modifying, that is present in this Redis cluster, that is not yet submitted in the S3 bucket because we have not updated this flow till yet. So let's see how we will update the flow. So what happens is like there can be two ways by which we can save a document. Number one is the autosave and number two is the manual save. So if the user B clicks a manual save, then what happens is like whatever the changes that is present in this canonical copy, this document editor service submit that information or submit that version or the snapshot of the file in this S3 bucket. But if the user A have not clicked on submit, then what will happen? We have to go with our autosave mechanism. So what will happen? On each and every 10 to 20 seconds, a save request will go from this document editor service to this S3 bucket, so that whatever the changes that had happened in every 10 to 20 seconds get persisted in the backend. Clear? So let me write it over here. So here what is happening, based on the manual save or based on the auto save, this flow is getting triggered on each 10 to 20 seconds. Means whatever the temporary data that is getting changed over here, that is getting persisted in this S3 bucket in the form of the versioning. Means for example at time 0 there is one version, then after 20 seconds there will be another mini version. Means maybe at the end of the 10 seconds there is one version and then there will be 10.1 in the end of the 20 seconds. So in this way a versioning or the snapshot of the document is getting persisted in the S3 bucket, so that whenever a new user is trying to collaborate or see the same document, so that we can give a near real-time view of the document to that user. Clear? Now once the second user, that is the user B, clicks on the edit to modify the same file, what happens is like we return the canonical copy of this document to the front end, so that both the user A as well as user B are on the same page. And that is why we need a OT service both in the front end as well as in the back end. Now one more thing is like here, if you see, we have kept the canonical copy in the Redis cluster. Now obviously this cannot be kept in the Redis cluster for an undefined period of time. So what we need here, we have to set a TTL over here so that we can delete it whenever it is needed. So for example, there is no user who is modifying a particular file, then that document will get deleted from here. Otherwise, till the point the document is getting updated, it will get persisted in this Redis cluster. I think this is clear. Now here, if you look carefully, when we were saving a versioning or the snapshot of a document in this S3 bucket, we have to somehow notify this database that there is a change in the version, so that the new user who comes to see the document can fetch the latest version from there. So for that, what happens is like whenever this document editor service create a new versioning, means whenever it creates a snapshot or a versioning after each 10 to 20 seconds, it not only save into this S3 bucket, also it does one more thing, that is it sends an event to this Kafka broker that is over here. Means a version got created for this particular document ID, and based on that this URL gets also changed accordingly. Means whatever the latest version of the document is there, we will change the URL over here, so that whenever a new user comes in, we can fetch the latest version from this blob storage. Now one more thing, Since there are multiple versions that is getting generated over here, we have to keep a track of all the versions that we are generating. And that is why here we need one more table that is called the version table. So let me draw the schema structure for that also. So this is how the version table will look like. So here we have an auto-generated ID, the document ID for which we are creating the version ID means the number of the version, who have created the time, the blob URL of that version file, and other metadata that is required. And all these things are getting generated and persisted with the help of this metadata consumer service. I hope this is clear. Now if you look carefully, we are almost done with everything that is required to design this system. Only thing that is pending, we have to optimize it a bit further. That is, here instead of fetching the document each and every time from the S3 bucket, we can optimize it further. And for that, what we can do, we can keep a CDN over here in front of this S3 bucket, so that whenever a user is trying to fetch the document in the read-only mode, we can simply fetch it from the CDN which is connected with this S3 bucket. Now there is one more thing. Now over here, if you look carefully, what we are doing in this versioning file is that on each and every 20 to 20 seconds, we are creating a version file in our backend. But in the real world, we might not have that many version of the file in the backend, because that will increase a lot of space in the backend. So what we do, we have to optimize this space management a bit more. So what happens is like, there is a reconciliation job that runs in the backend. So here we are having a reconciliation job or a reconciliation service that runs in the backend. So what happens is like, whatever the events that get generated over here by the user on a particular session, all of them are stored in this DB, right? Now, once that session ends or there is no further user who is updating this document, what happens is like, this reconciliation jobs runs, and what it does, it actually clear all the data in the backend. So it will first fetch all the operations from this database, and it will fetch the last solid version of the file from the S3 bucket. So what is happening is like, maybe a couple of users are modifying a particular file, and each and every second a minor version of a particular file is getting generated. So for example, at the very initial state, the version of the file was 10. Now once the user have started modifying the file, we are generating the intermediate version that are nothing but the minor version. In this way, all this minor version is getting generated in our backend. And maybe after the end of 15 to 20 minutes, when they're all done with all the changes, the version of the file is 10.0.100. Now what happens is like, this reconciliation job takes the initial version from this S3 bucket, and it takes all the operations that had happened within this session. And this reconciliation job performed all those operations on that initial version of the file. And once that reconciliation is done, finally we get a final version or the updated version of the initial one. And thus at the end of the session, a second version gets generated, that is 10.1, and this 10.1 is actually get persisted in the S3 bucket, and all other minor versions that we have generated during the session time, that we delete it from the backend, so that we can optimize the space from the S3 bucket. Similarly, whatever the operations that we have gathered during the session, that also get deleted from the backend. So at the end of the complete session, once the reconciliation job ran successfully, at that time you have moved from the initial version, that is 10, to 10.1, and we have deleted all the intermediate version that we have generated during that edit session. I hope we are clear with how we are generating the versioning over here and how we are saving it in the backend in the most optimized way. And also similarly over here, this reconciliation service also have to notify this database that the final version of the file got generated, and thus you can update the URL over here. So an event will get generated in the Kafka broker, and thus our metadata service will consume that and will update it accordingly. I hope this is clear that how the entire flow is happening in the backend for updating a Google Docs with one or multiple users in a collaborative way. So here if you look carefully, we have more or less fulfilled all the requirement that we have gathered at the very beginning. That is, user can create, update or delete a particular document. Multiple user can edit the same document simultaneously. User will be able to see each other changes in near real time and the versioning of the file. Only thing that is pending is the cursor position of the other user. So how this is done? This is very easy. Since we are using a WebSocket connection, so whenever a user is trying to edit a particular file, we send the position of the cursor with the help of this WebSocket connection. And for each and every user, the cursor position gets persisted in this Redis cluster, so that in case the connection of the user breaks anytime, when he further joins, he can again see the cursor position where he left. So that is why we are persisting it in the Redis cluster with a TTL. So here if you look carefully, we have more or less created everything that is required to design a Google Docs where multiple users can edit a document simultaneously. Only a small thing that is missing, that is here if you remember, I told you that there are some API endpoints that are still pending. That is, for example, if a particular user want to fetch a particular version of the file, then at that time how we will fetch? We can fetch it in the same way by which we were fetching this thing. That is, we will fetch it with this URL. Here there will be additional one more thing, that is the version ID that we have to send over here. So here we are sending the document ID and the version ID which we want to fetch. And from where we will get the version ID, that we will get from another GET API that will look something like this. So this is how the two endpoint will look like. So here the first one fetch all the versions of a particular file based on the document ID, and the second one opens a particular version of the file based on this version ID that you are passing. And whenever you are trying to fetch a document with the help of this URL, what will happen? It will simply fetch the latest version that is present over here in the URL. Clear? So here if you look carefully, we have completed everything that is possible to ask during a technical interview. So if you have liked this video and found this video useful, do not forget to like, share and subscribe to my channel and hit the bell icon so that you never miss an update from my channel and you are always ready for your next interview. So see you on our next video where we will be solving another video on technical interview. So see you on our next video. Thank you.